The purpose of this video is to expand our knowledge of special quadrilaterals to include the kite and the square. First things first, what is a kite? The kite that you fly in the sky is a great example of a kite that we're going to study this year in geometry. It's a quadrilateral, or any quadrilateral, where two pairs of adjacent sides are congruent to each other. So this is a little bit different than the parallelogram with respect to the fact that in the parallelogram, both pairs of opposite sides have to be congruent. In the kite, both pairs of adjacent sides have to be congruent. So if you notice in the picture, they've marked side AB congruent to side BC, and then side AD congruent to side DC. The properties that you need to know about kites is that the diagonals of the kite are always perpendicular. The kite is always going to have at least one pair of opposite angles that are congruent. It's always going to have at least one diagonal that forms two congruent triangles. A kite is always going to have at least one diagonal bisecting the pairs of opposite angles, and at least one diagonal bisecting the other. Now, here's where things really start to get cool. A square is a quadrilateral that's also a rectangle. Remember, in order to fall into the rectangle family, our quadrilateral has to have 4 right angles. And the square meets that requirement, making every square a rectangle. In addition, the square is also a rhombus. Remember that in order to fall into the rhombus family, a quadrilateral has to have 4 congruent sides. Well, the square meets that criteria, making all squares into a rhombus. And the kite also. In order to fall into the kite family, a quadrilateral has to have 2 pairs of congruent adjacent sides. The square meets that criteria, meaning that the square can also fall into the kite family. The square, I think, is a really cool, nifty individual. Because it has all of the properties of the rectangle, the rhombus, and the kite, it fits into all of those categories. All right, down at the bottom, we want to take a look at 2 examples where we can use and apply this new knowledge that we've learned regarding the square and the kite. Number 1 says we're given the square ABCD with the following side lengths. They're asking us to determine the value of x and then find the length of a diagonal of the square in simplest radical form. Everybody's favorite words. All right, like always, first thing I'm going to do is go draw a nice picture that I can use in order to set this problem up. So there's my square ABCD. I'm going to go ahead and label AB 2x minus 14. And label BC x plus 15. Because this fellow's a square, I know that all 4 of his sides are congruent, making side AB equal in length to side BC. So now I can go set up my equation, 2x subtract 14 equals x plus 1. All right, so I'm going to go ahead and continue solving this equation. And when I do, I find that the value of x is equal to 29. That means this side of my square is 44. It also means the length of AB is 44. So in the first part of the question, they asked us to determine the value of x, which is done. In the second part of the question, they've also asked us to find a length of the diagonal. So I'm going to go ahead and draw my diagonal in there. And in order to find the length of the diagonal, I'm going to go ahead and consider the triangle formed, or the triangles formed by the diagonal. So I'm going to start by going ahead and looking at that little green triangle up at the top of my square. I know that that triangle is a right triangle because all of the angles in a square are all right angles. I know that triangle is an isosceles right triangle because it has two legs that are the same length. And I remember that for my isosceles right triangle, the length of the hypotenuse is always equal to the square root of 2 times the length of either leg. So my hypotenuse in this green right triangle is side AC, and its length is going to be equal to the square root of 2 times the length of the leg, 44. Or in other words, the length of AC is going to be equal to 44 square roots of 2. Now, if you didn't happen to notice that relationship, you might also know that you've got a right triangle where you know the lengths of the two legs. You can use Pythagorean Theorem to find the length of the hypotenuse. So there's two possible ways that you could solve for the diagonal of a square ABCD. As long as you know one, you're in good shape. All right, in the second example here, they give us a kite where they're giving us some pieces of the diagonals and asking us to determine the lengths of the sides of the kite. So I'm going to go ahead and just like I did with a square, I'm going to start out by looking at that red triangle. I know that the diagonals of a kite are always perpendicular, making that red triangle a right triangle. Because the lengths of the two legs are 12 and 12, I know that like the square, this is going to fall in the category of that isosceles right triangle. So the length of my hypotenuse is going to be root 2 times the length of either leg. So I've got that isosceles triangle going on here again. And again, if I had wanted to, I could use Pythagorean Theorem in order to find that relationship. So again, with that 45, 45, 90 relationship, we know the length of the hypotenuse is always equal to the square root of 2 times the length of either leg. So in this particular case, our hypotenuse is going to be side xy, and that's going to be equal to the square root of 2 times the leg, which is 12. So xy is equal to 12 square roots of 2. And that makes zy also 12 square roots of 2. All right, then if we want to consider the other legs of this kite, I'm going to go ahead and take a look at the blue triangles. I don't notice any specific particular relationship between the 12 and the 20. But again, what I do know is that right angle there makes those little blue triangles right triangles. And any time I know two sides of the right triangle, I can use Pythagorean Theorem in order to find the third side. So the first leg, 12 squared, plus the second leg, 20 squared, that has to be equal to the length of my hypotenuse squared. When I go ahead and punch that into my calculator, I find that the length of segment, or I'm sorry, I find that c squared is going to be equal to 544. So c is equal to the square root of 544. And now it doesn't specify whether it wants me to leave this in radical form or round it to some decimal or some integer. So remember that when it's unspecified, they always want you to leave your answer in simplest radical form. So I need to look at the number underneath my radical sign and find the largest perfect square that'll go into 544. And the largest perfect square that'll go in there is 16, and it'll go in there exactly 34 times. So in simplest radical form, the length of side WX is 4 square roots of 34. And the length of side WC is also 4 square roots of 34. And now I've successfully done what has been requested and found the lengths of the sides of the kite. Okay, up at the top of the next page, like always, I want you to summarize the key ideas. What are the important takeaways that you need to remember from this video? And then see if you can apply those important ideas in order to solve the questions on page 18.